right, the next and last example that we'll be doing this evening is going to be sample problem 1318. Sample problem 1318 is looking at two railroad cars that are moving and are going to be colliding with one another. So we have railroad car A. It is 20 megagrams. It is going at a speed to the right of zero point 0.5 meters per second. It is going to collide with car B, which is 35 megagrams, and it is going at a velocity of 0. So it is at rest. So it's just standing still right now, and it's going to get hit by car A. After the collision, the 35 milligram car is going to move to the right at a speed of 0.3 meters per second. So they're not sticking together after the collision, but B is going to continue on. So you can see here we have a VB prime. Okay, so VB before, VB prime after. Okay, and what we want to find out is how fast is car A going? Okay, once it's done, after after the collision. So what's happening? And then they want us to determine that coefficient of restitution between the two cars. Okay, between the two cars. So we'll be figuring out how fast A is going after, so VA prime, and then using that value to calculate that E, that coefficient of restitution. All right, so this is sample problem 1318. It's page 891. Okay. We want to find E. Okay, and that's the coefficient of restitution. The reason I'm not going to write all the givens here because we're going to actually show the givens in our diagram. Okay, so first of all, I'm going to say that my positive is going to go to the right. So this is my convention. All right, and I'm going to draw a rectangle for railroad car A and railroad car B. Okay. So this is going to be A, this is going to be B. I know that A is 20 megagrams and B is 35 megagrams. I'm going to put a plus symbol between here because we're going to add together the momentums of each of these. I know that velocity A before is equal to 0.5 meters per second, and it's going to the right. Okay. And then I do also know that my velocity B is equal to 0. So this is the before, okay? It's going to be equal to the after. So we're going to do another rectangle for A plus rectangle for B. 20 megagrams, 35 megagrams. Velocity A prime, we don't know, okay? We don't know what that value is. And then our velocity B prime is equal to 0.3 meters per second, and it's going to the right, okay? Now, because we're just dealing with the two railroad cars, okay, there is no outside, impulse acting on this, okay? So the before momentum is going to equal the after, which is that conservation of linear momentum. So that's going to be, if you would, our approach. So we're going to use the conservation of linear momentum. Okay. And that's going to make our expanded equation here, the mass of car A times its velocity A, plus the mass of car B times velocity B. So this is going to be our left side, the before side. It's going to be equal to mass A times velocity B, velocity A prime, plus the mass of B times velocity B prime. So the after side. So before momentum has to equal the after momentum. So now we're going to use the values that we know and plug them in. So if we look at first our momentum at A, notice that it's going to the right, and anything going to the right is positive. So it will be a positive momentum. So mass times velocity. All right. Now, notice that we're in megagrams. All right. Since all of the values are in megagrams, I'm not going to convert to kilograms just to add zeros. All right. So our numbers will come out exactly the same. So I'm going to keep everything in megagrams. And it just doesn't add zeros to my final answer. My final answer is going to be for velocity. So the units will all cancel out. If you wanted to convert to kilograms, you certainly are welcome to, but it's just you're going to be dealing with extra zeros. So I am going to just keep it in megagrams. So this is going to be 20 megagrams times 0.5 meters per second. So that's the velocity. Plus, now we have 35, right? But this velocity is zero. So this ends up being zero. So we're just going to add zero here. Okay. It's going to be equal to mass A is going to be our 20 again, but we don't know what the velocity of A prime is. So this is going to be what we're going to solve for. Plus the mass of B, which is 35, times 0.3 meters per second for the after velocity. Okay. So our only unknown here is our velocity of A prime. So let's go ahead and solve for that value. Now, once you have your value calculated, you're going to notice that you have a negative out front here. What that means is when we did our math here, we kept this as a positive value. So it assumed the velocity going to the right. But because we ended up with a negative, that means that it's actually going to be going to the left. So going to the left. Okay. And that's okay. It's no big deal. Now, when we use this value, though, in our equation or a calculation for the coefficient of restitution, we will hold that. Okay. So did everybody get the negative 0.025 meters per second? So after collision, it's going to actually go back this way, and it's going to be going pretty slow, 0.025 meters per second back to the left, while the velocity of B kind of shoots out to the right, going 0.3 meters per second. Okay. Now, the coefficient of restitution. So looking back at our equation sheet, we want to calculate this value using the equation we see here. Okay. So our E is going to be equal to velocity B prime minus velocity A prime divided by velocity A minus velocity B. So adding in our values, we're going to have 0.3 for velocity B prime minus, and then we're going to put the negative in there, minus 0.025 divided by 0.5 minus 0. Okay. Now these two, as you can see, become positive, right? And your coefficient of restitution should be 0.65. All right. So calculating first the velocity of A prime so that we can then use it down here, and then our coefficient of restitution, 0.65. So any questions on the collision problem that we see here? Very classic, physics type of a problem, but you probably didn't calculate the coefficient of restitution. That might be something that is an adder here for us. Okay, if there aren't any questions, then I am going to stop our recording here.